For graphing sine, we're going to use the key point. So if you look at your unit circle, if you start at 0 radians, you'll notice the y value, because sine is always the y value, is 0. Then, if I keep moving around the unit circle till I find a whole number, I get to pi over 2, or 90 degrees, where the y value is 1. Keep moving around the unit circle till you figure out where y is a whole number, and you'll get to pi, where sine is back to 0. Continue this, you'll get to 3 pi over 2, where the y value is -1, and back to complete the circle, and your y value is 0. So these are the key points that I'm going to plot for sine. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. Now you can continue this pattern on because sine repeats itself. Up to 1, down to 0, down to -1, back up to 0. Down to -1, back up to 0. So sine makes a curve that goes on forever, which leads us to the fact that the domain is all real numbers, or -infinity, +infinity. The maximum value, well, if you look at the maximum value on your unit circle, you'll find that it only goes up to 1. So our maximum value is 1. Now if we're looking for the minimum value, using the unit circle, the lowest number on the unit circle is -1, which means my range is -1 to 1, and that's inclusive. Sine is a periodic function because the y values repeat. Its period of the sine function, you'll notice that one curve goes from 0 to 2 pi. It goes up and down. So the period of the sine function is 2 pi. Sine is an odd function and has symmetry with respect to the origin. The y-intercepts, or the zeros, were 0, notice here, pi, 2 pi, I can keep going, 3 pi, 4 pi, goes on forever, and our y-intercept was 0, 0.